Welcome to another simple GIS project. In this project, we are going to work on Nigerian population estimate, count and density for states, local government, wards, cities, senatorial district, federal and state constituencies if possible. So to the best of my knowledge, as at the time of recording this video, there is no official figure from the federal government of the country as far what the population count is. If you make a Google search, there are many sources that provided a round head figure for the population count in Nigeria. And most of the figures are around 200,000, 200 million plus. You will come across so many sources that provided the rounded figure of Nigerian population. And most of the figures you find are around 200 million plus population as at year 2020. If you go to the National Population Commission's website, as at the year 2006, when there was census count in Nigeria, the rounded figure was 190 million population. And presently, we have close to 250 million, as stated by Worldpoporg, endorsed by the National Population Commission. As you can see, the website is embedded right in the National Population Commission's website. So the population of Nigeria as at 2000 is this, as at 2020 is that, as at 2019 is this, and continuously. So these are just projections or estimates made by these organizations. So in this project, we are not just looking at the entire population of the country, but we want to drill down the population towards cities, senatorial districts, local governments, and so on. So here on the Worldpoporg website, we have the population of some selected cities, but this is not enough for the kind of project we want to work on. So we really want to have the population for various cities in the country and the local government, and also the wards level. So here I found this source, which is on worldpoporg.org. So they have the Nigerian population estimate available for download in GeoTIFF format, which is at the resolution of 3 arc, that is approximately 100 meters at the equator, and it's available to download for free. You can head over to this URL, which I'm going to provide in the video description, and you can download the GeoTIFF image. So with the aid of GeoTIFF, we can now extrapolate the population for any region that we want. So if you have a city, if you know the extent of a city, which you can digitize using a polygon, so you should be able to get an estimated population figure for that city. So let's take a look at where we can get the data. So for the population, we are going to use this GeoTIFF image, which is a raster data. And then for the administrative boundary of the country, I'm going to use this shapefile. You can download this shapefile from this source, or you can download this file from here, where you can get both the state, local government, and the ward administrative boundaries. So I also have the link on my blog where you can download it directly. You can get it from this Buy Me a Coffee download link or from this Google Drive. So with that said, I'm going to open up my QGIS environment and then load the shapefile and the data. So let's load the raster data we got from that source. So here's the raster data. I will open it up and then add it to the map canvas. So here we have the raster data we got from the Worldpoporg website, which is here. So the size is just about 58 MB or 59 MB approximately. So download it and load it into your environment. So these darker spots are actually places where we have the higher populations. And then the white spots are places we have lesser populations. So I can use the identify tool to click on any spots to identify the figure on that at that particular region. So here we have this figure on the raster. So at that location we have approximately 112 people. If I click on a different location, you can see that at that location we have approximately 31 people. So this raster represents population data, not elevation data as usual. If you recall, you can use you can store any kind of value, any kind of data in a raster data set. It doesn't have to be digital elevation model, that is elevation data all the time. You can store temperature, you can store pressure, you can store any kind of variable. So here we have population stored in the raster format, and we are going to use it to extract the population by a given polygon. So let's start. Let me load the shapefile layers by going to the add shapefile button here, and then I will navigate to the location where I have my shapefile. So the first things first that we will load is the state. So let me load the state polygons. So here I have the state polygons. Let me make it hollow, remove the background color so that we can see the underlying raster data. So here we have the state polygon superimposed on the population raster data. So as you can see, for each polygon boundary, if I select the polygon, for example, if I select Kaduna State, you will see that the pixel value that is enclosed, that is beneath the state polygon boundary, will give us the total estimate of population within that state. So likewise, if I do the same thing for this polygon, the underlying pixel value, the sum will give us the population within that state. So how do we do that? How do we do this? So we are able to do this using a tool that we can get from the processing toolbox in QGIS, and you can find it under the raster analysis toolbox, and it is called the Zoonal Statistics. So when you open it up, you see that from the description of the algorithm, it is an algorithm that calculates the statistics of a raster layer for each feature of an overlapping polygon vector layer. So we have two layers. The raster layer, we select it. The raster band, we only have just one band for this raster. Then the vector layer, we only have a vector layer currently on the layer panel. And then the output column prefix. Here we can use any prefix for the output column. Maybe I will call it pop for population, then underscore. Then the statistics to calculate. We have various different kind of statistics to calculate. So what we are actually interested in here is the sum. So the sum of the values for each underlying pixel within each polygon, each state polygon. So I will uncheck others, but you can give them a try if you want. If, for example, you want the maximum or the minimum pixel value, you can use this. But this is of no importance for this project. So what we're interested in is just the sum. So the sum of the pixel value will give us the population in each state. So select it, then click on OK. Now we'll have just one option selected. Then the next thing I need to do after selecting my options, I will click on Run. So if everything works successfully, we should now have a column within the shapefile that will contain the population of all extracted from the underlying pixel for each state. So it is complete. I'll click on Close to close it. Then I'll go back to the shapefile. Right click and open up the attribute table. So this is the population sum for the shapefile as extracted from the pixels. So as you can see, we have Abia State will have this population as extracted from the pixel. Abuja will have this population. Adamawa and up to the last state, which is Zamfara, in alphabetical order. So here, if you notice, there is one thing that is obvious here. A population sum cannot be in fraction. So we need to approximate it. So to do that, I'm going to use the field calculator and then create a new field that will round up this population sum column. So I'll go to field calculator. Then I'm going to create a new field, and then I'm going to call it population, maybe 2020. That's population for the year 2020. Then the output type is going to be an integer, maybe integer 64 or integer, just integer. Either way will work. The only difference is that integer 64-bit will handle more larger number than the whole number integer. So whichever one we use should work for us. So what I'm going to do now is to use the number of this field. So I'm going to use the value from the population sum we extracted from the raster. But if I use it, it will copy the values the way they are here. But what I need to do is to round it up. So I'm going to use a function called round and then enclose the value. So what I'm doing, I'm rounding it up. And from the preview, you can see that the value has been rounded up compared to when I remove the round function. If I just put the value directly, you see that the decimal place will still be there. But if I use the function round and then the name of the column that I'm rounding up, you see that the value is now a whole number. So I will do that and then click on OK. And then I will now have a rounded figure. So for Abia State, I now have a rounded figure instead of the earlier one with fractional decimal places. So I can now delete this column since I don't need it. I can now delete the population sum since it's of no importance. And then we now have this. So this is the population count based on the given raster data we obtain from the Worldpop website. So each state now has this figure. So let's verify what we had. For example, if I select Lagos State. So this is Lagos State. If I go back to the attribute table and then go to Lagos State. So according to the raster data source, Lagos State has approximately 12.7 million population. So I can easily verify that by going to Google and then make a search on the Lagos State population. Lagos State population 2020. Let's see what we have. So the figure I'm getting here is around 40 million. 40 million, but I think we are still in order because this result will probably be the one for 2022. We can trust the data source here and rely on what is giving us. So it says 12.7 million here. So we can just try it, rely on it and make use of it the way it is, since at least it's a reliable source. And you can see the method they use to estimate the figure. So this is something that could have been done by the federal government if things are working the way they are supposed to be. At least by now, we shouldn't be relying on foreign bodies to get rounded figure or estimates on the Nigerian population. But that is just by the way. And I'm aware that it's an effort to conduct the national census maybe sometime this year, hopefully, as listed on the National Population Commission's website. So I pray that it works out and Nigeria should have at least a more reliable head count of its populace. So let's confirm for another state, maybe Kano State. Kano State. So the population in Kano State, it says 4 million. So let's see what we have on the data. So here I'm going to select Kano. It should be Kano. Then go back to the attribute table. Then Kano. Here on Kano, I'm having 14 million. So I think what I'm getting here, this should probably be 40 million, not 4 million. So this source is wrong. It can never be 4 million, definitely. But if I go back to the Wikipedia page, yeah, as you can see, Kano is 12 million. So we can trust or rely on this data source then to continue with the project. So next, we are going to extract the population for local government, which is even difficult to get, even with the foreign sources. They hardly give you the population of the local government drilled down to wards and even cities. So to do that, I'm going to off the state layer and then add the local government administrative boundary. So here's the local government administrative boundary. Open, add, and then let me make it transparent. I double click and then select the style to no fill. So here are the local government of the entire country. So I will repeat the same zonal statistics to extrapolate the population for each local government. So I'll go back to my processing toolbox. Then under raster analysis, I will select zonal statistics. Then the raster layer is just the population raster file, which is just which just has a single band. That's the gray band. Then the vector layer to calculate the zonal statistic for is going to be the LGAs layer. Then the output, let me just call it pop underscore. Then the statistics to calculate is going to be the sum, just as we did earlier on. Then click on run. So this will run and then extract the population from the raster layer for each local government, as we have done for the state earlier on. So it is complete. I can now close the algorithm. And then now if I go back and check the attributes, I now have the sum of population for all the local governments in the country. So all these local governments, these are their populations. I can remove the fractional parts by rounding it up. So I'm going to create a new layer called pop year 2020, and it's going to be an integer field. Then the name of the column is pop sum. So I'm going to round the values from this column into a new column. So round to no decimal place. So click on OK. And then now I have a new pops population for the year 2020 for each local government. And this unwanted column, I can delete it from the record. So save and then tabulate it. So this is the population count for the year 2020 for each local government. So if I want to get the local government with the highest population, I just need to sort ascending, and then as you can see, only Mosho in Lagos State is the local government with the highest population count based on this given raster. So it is not surprising if the local government with the highest population is coming from Lagos. After all, Lagos has the highest population when you're looking at states. Then the next thing I would like to do is to do it for the ward's administrative boundary. So let me minimize this and then add the ward boundary layer. So these are the ward's boundary layer. I'll open it up, close, then make it transparent. Double click to open up the property dialog box. Under symbology, set it to no brush. And these are the wards in Nigeria, in the country. So from the wards, I'll go to Zonal Statistics, select my raster, then select the wards boundary. Then the output, I'll just call it up, and then I'm just interested in the sum. Click on OK, and then click on run. So this should run and then return the population of each ward within the country. Let's close the algorithm dialog box, then go back to the ward layer and then open up the attributes of the ward layer. So here we have the population count for each ward within the country. I can calculate the whole around the figure by creating a new column using the field calculator. I'll call it population 2020 and then pop sum. I'm rounding off the values in this column into a new column here. So click on OK. So this should create a new column, and then I can delete the older one that has the fractions. So here I now have the ward's administrative boundary with all the populations here. So this kind of figure is difficult to get when you search for the ward's population of a particular ward. It's difficult to get, but using this raster, we're able to extract the value. So we can also do that for cities. So I have some selected cities here. Let me first of all add the point location of those cities. This is it. So the cities are this. We have some of them are in different states, while some of them are in the same state. So we have the city of Ilori, Lagos, Zaria, Kano, Ibadan, and so on. So these are some major cities within the country. And it's expected that we need to have the population count for those cities. So the population count for the cities will only be possible if you can get the city extent using a polygon. For example, this city, which I believe should be Sokoto. So the city of Sokoto, at least we can see that the city should cover the entire of this area. Or better still, we can use add a background map, a Google base map. So here I'm going to use the quick map service to add a Google base map. So let's add the road map. So if you don't have, it's a plugin. If you don't have it, you can install it using the plugin manager, manage and install plugin. So you can install the quick map service plugin. So now that I've installed it, I can see that the extent of Sokoto city should be somewhere around here, which I can now digitize using the polygon shapefile. So I can use a polygon to now represent the location of the city. So the same thing for other cities. If I zoom to a different location to find out the city there, for example, the Lagos or Ikorodu city. So as you can see, the Ikorodu city should probably be the entire of this area, which we can get from by digitizing the polygon. So this is the city of Ikorodu, which is in Lagos State. So by the time I need to create a polygon for the entire of this area. So it is very simple. You only need to create a new shapefile, layer, then new shapefile. The shapefile will now be a polygon type. Then you can now use it to now digitize the extent of those cities. So I have already done that, and I'm going to add it as a layer. So this is the Nigerian city polygon shapefile. If I add it, you now see that I have the extent of Ikorodu city. Let me make it transparent. So assuming this is the extent of Ikorodu city, based on my assumption or based on my findings, and then this is the extent of Abeokuta, the city of Abeokuta, based on my findings. Then other cities too are now represented using polygons, as seen here. So you need to have the cities represented in polygons for you to be able to extract the population count for the cities. So what we need to do now is go back to our algorithm, and then we select our raster. Then we select the Nigerian city polygon, and then we now put in a prefix for the output column. Then we are just interested in the sum, and then click on run. So this will now extract the population based on those extent of the cities. If I open up the attribute table, I should now have a new column for each and every city that we're interested in. So I can now calculate a new field, which I'm going to call pop 2020, which is going to be a rounded figure. Okay. Then I can delete the old one. So this is for cities. So Sokoto city have about 784,000 population. Lagos city has this, Abeokuta has that, and so on. So let's check Google to verify our claim. So on Google, I'm going to search for maybe something like Lagos city population 2022. I cannot find, this is probably, this should be for the state, not for the city. But I think there is a source here where we have population for cities on the Worldpoporg website. Yeah. So main city population, main city by population in Nigeria. So Lagos, according to this record, Lagos has 99 million city. So most likely our assumption for the extent of the Lagos city was wrong. If you check what we have on the polygon. So this is supposed to be the polygon that represents Lagos city. So maybe by the time we extend the polygon to cover some of this area or the entire of this region, that should be the Lagos. But I think it is wrong for you to assume that this part is also part of the Lagos city. This is Ota, this Alasia, Ikeja. I think the Lagos city, the Lagos island should be different from Ikeja, another part of the Lagos state. So probably the data we saw online is looking at the whole of this area as Lagos city, including Lekki and other places. So but depending on the kind of research work you're doing, when you define your extent, you should be able to extract the values as we have done earlier. So let's take a look at another one like Sokoto. So the city of Sokoto, which is somewhere here. So let's check the population we have. So the population here says 700,000, while what we have here on the website is 500,000. So it's still within the range. Let's see another city that we did. Maybe I think we also have that of Ilori. So here said 814,000. So let's check the attributes for Ilori. So Ilori here is about 1 million. Yeah, it's about 1 million, which is also within the range. Difference of about 200,000, which is also within the range. So that is how to get the population count from this very data source we use, which is the population, which is the Worldpoporg data set available in raster format. So now for each of this layer, I want to calculate the population density. So I'm going to start with the state. I'll open up the attribute and then create a new column that will have the population density. To calculate the population density of each state, we first of all need to know the size or the area, the landmass of the state. Then we can now divide the population count by the land size or land area for the state. So the expression is given by this formula. Here you can see the formula for calculating the population density of a region. Is given by N, which is the total number of population, divided by A, which is the land area covered by the population. So in our case, this is the state attribute table. We have the population count. So we need to have another column that has the area for each state. Then we can now divide the population by the number of the land size, by the size of the land mass to have the population density. So let's quickly do that. So first of all, I'm going to add a column that will have the land mass of each of the states. So I will do that by going to the field calculator. Then I'm going to create a new field. Let me just call it land mass. So the land mass is going to be a decimal field, and then there is a function called area. It is under the geometry, is used to calculate the area, as you can see from the description of a polygon. So this return the area of a polygon, irrespective of the ellipsoid. That's the coordinate reference system of the polygon. So it will return the area in square meter. So if I double click on the function to add it, I have the area function like this. And then as you can see from the preview, the output preview, this is the area for the first polygon. So if I click on apply, we should now have the landmass area in square meters. But I think it would be more appropriate if we have the landmass area in kilometer square. That will make more sense than having this large number in square meter. So let me delete the column and then recalculate it in kilometer square. So this is, the name is going to be land mass. Then in brackets, can I have the unit in brackets? No, it's 2. Land mass in kilometer square. Okay, then it is going to be decimal. Then the function is given by $sign area. That's the name of the function. Then I'll simply divide by 1 million to have it in kilometer square. So 1 and then 6 zeros. So this will give us the value in kilometer square instead of meter square. And if I wish, I can just round it up. Let me use whole number so that I'll have a rounded figure. Let me see if this will give us a round figure. So this is better. So we now have the landmass in kilometer square. So Abia has the landmass of 40,796 kilometer square, and the population is given by this. Abuja has this. Borno has this. Other states too. Delta State have a landmass of 16,986 kilometer square, and the population is given by this value. So now with this, I can now divide the population divided by the landmass. If you look at what we have here, the number of people divided by the landmass will give us the population density. So I'll go back to my field calculator and then I'll create a new field. I'll call it pop density. Or pop dense. Population density. Pop dense for population density. And then let me make it a whole number. And the formula is the population divided by the landmass. So each state will have this calculation done on it. The population of the state divided by the landmass will give us the population density of that state in kilometer square. So if I apply it, so we now have this population density for each state. If I sort it, you will see that the place with the highest population density are Lagos, Anambra, Imo, Akwa Ibom, and Abia. These are the first 5 states that have high population density. So as you can see, Kano is coming at the 7th position, even though Kano has the 2nd largest population, but its population density is not as high as other states because it has a relatively large landmass. And then the states with the least population density is Taraba State and Niger, Taraba, Yobe, Niger, Borno, because these states have very large land masses. So their population density will definitely be very low. So that is that for the state. And we can now save our shapefile. So we are going to repeat the same process for other layers. So I'll go back to the state I've done for state. Now I'll go back to the LGA, local government areas open up the attribute table. I'll first of all calculate the area. So I'm going to call it area, and then yes, integer is okay. Then the area given by this function, area function, then divide by 1 million to have it in kilometer square. So these are 6 zeros. So we now have it in kilometer square. So click on OK. So here we have the area of each of the local governments in Nigeria in kilometer square. So I could have called it landmass. I think instead of area, I would have changed it to landmass. But that is not a problem. At least area and landmass they are almost the same thing. And it doesn't matter whatever name we use here, as long as you know what the contents are. So the next is going to be the population density. I will now calculate the population density, which is going to be a new field for all the value, and it's called pop dense for population density, and it's going to be the population at that local government divided by the landmass area at that local government. So I will click on OK to apply it. So here we now have the population density of all the local government, and you can see the local government with the least population density are these ones in Adamawa, Togon in Adamawa, Gashak in Taraba, and then Kunduga in Borno. They have the least population density. Then those with the highest population density are in Lagos, as you can see. In fact, the first 5 local governments with highest population density in Nigeria are located in Lagos State. So that is that for the local government areas. The next is going to be the ward. So I'll open up the attributes of the ward layer, calculate the landmass area and then the population density. So field calculator, then I'll calculate the landmass. The landmass is going to be the area function divided by 1 million to have it in kilometer square. So if I apply this, I will now have it in kilometer square. So these are the landmass of all the wards in the country. And as you can see, we have all the values populated. Then we can now calculate the population density. So pop dense is going to be a whole number integer, and then it's going to be the population at the ward divided by the landmass. That is the formula for calculating the population density. So let's population at a given area divided by the landmass of that area. So let's have it. We now have the population density of all the wards within the states. So that is that for the wards. The same is also applicable to other layers like the cities. If you decide to do for the cities, open up the attribute table, then we'll calculate the area or the landmass of each city. It's going to be applied to all landmass of the city, which is just the area function. Then convert it to kilometer square. 1, 2, 3. 1, 2, 3. So we have 1 million divided by 1 million to have it in kilometer square. When you click on apply, you should have the landmass. This is the landmass. So the city with the least landmass is Lagos, followed by Zaria, and then Oyo. Then the ones with the highest landmass are Ibadan, Port Harcourt, and Benin City. Then now let's calculate the population density. Remember, the formula for calculating the population density is given by number of people, that's the population count, divided by the land area. So our pop density will be the population field divided by the landmass field, and then we should have our population density as well. So the highest population density is the city of Kano, and then the least population density is the city of Wari. So this is how to calculate the population density of a given area. Then another thing that I would like to show you is, probably if you want to have the total population count of the entire country, you can simply sum up the entire values for all the states, or you can easily match the state administrative layer and then extract the value from the given raster. Or let's say we want the population count of the geopolitical zones. So we know that a geopolitical zone is made up of several states. So we can either sum up the value of the states that fall within that geopolitical zones, or we can merge the layers, merge the polygons, and then extract the values, the sum of the value from the raster. So that is that. And the same principle is applicable to the senatorial districts and federal and state constituencies. For senatorial districts, we know that they are made up of several local governments in the state. I think about 6 or 5 local governments makes up one senatorial district. So the sum of those population or population density within those local governments will make up the population count or population density within that senatorial district. The same is applicable to federal and state constituencies. So I don't need to do that. Probably you should be able to do that by yourself. So the last thing we will do is to export this data into a friendly format that we can share with other users. So for the state, we can simply right click and then save as. So instead of saving it as in shapefile format, we'll now use Excel, CSV format in Excel. So I'll navigate to where I want to save the file. I'm saving it here on the desktop, and then I'll give it a name, the Nigerian state population count and density. So let me just leave it at Nigerian state population. So if I click on OK, and then I can click on OK to export it. So this should export the attribute table into a CSV file, which I can open in an Excel program. So this is how the final output would look like. And you can export that of the local government, the wards, and the cities. And you can easily share this file with other users, especially those who are non-GIS users. They can open this file easily with any spreadsheet application. So that is it, and I hope you enjoy this project. I hope to see you in the next one. Have a nice day.